Hello, this is Mr. Stansbury. I'm going to take you to the 16 F notes on sine functions. At the end of this, you should be able to say I can find the vertical and horizontal dilation of a sine function as well as its vertical translation. Okay, and also I can find the equation of a sine graph. So with that, let's take a look. We're going to look at investigation number 3 from page 533, and it says to graph y equals sine x and compare it to y equals 2 sine x, and then sine x versus 0.5 sine x, and negative sine x. Okay, so actually have a nice little graphing program here for that, and that will help us out with that. Okay, so here is regular old sine of x. Okay, now if we take this and compare it to what we did on the last section here, which was 16E, that was the Ferris wheel problem. Now, if you remember the Ferris wheel problem here, we had the Ferris wheel, and the guy got on down here, and all that kind of good stuff. What this is saying here is sine, or actually, this is your start. So this is where he is going to start for a sine curve. Okay, so that's 0 degrees, and then here's 90 degrees. Here's 180 degrees, and then here's 270 degrees, and then this is also 360 degrees because we're back at the beginning. Okay, so taking a look at this graph here, you're starting at 0, and then you're going up at 90 degrees, you've maxed out, and then back at 180 degrees, you're back where you started, at least the same height, and then at 270 degrees, you're at the very bottom. And then 360, you're back at the beginning, and then you go and start it over again. Okay, so this is called a sine curve, and this is used a lot in math and science. Okay, so first thing they wanted us to do is show that difference with 2 times sine of x. So what does the 2 do to the graph, basically? So we graph that, and look, it affects how high and low it goes, or its amplitude. Right? So this 2 out in front is seeming to affect the amplitude. Right? Let's see what the 0.5 does. The 2 made it twice as tall. The 0.5, hopefully you would figure out, is going to make it half as tall. Okay? So then now the amplitude is smaller. Okay? Now the negative sine x is just going to take that graph, and instead of starting by going up, it's going to actually start by going down. Okay? So back to our Ferris wheel example. This 2 sine x, basically that means that this Ferris wheel is twice as big. Okay, so it goes up twice as high and goes down twice as low. Okay, this 0.5 means that the Ferris wheel is half as big, so it's a smaller Ferris wheel. And then this negative sine x basically just means instead of going up and around this way, we're actually going to go down this direction. Okay, so it's basically you're going to switch directions. All right, so that's investigation 3. Let's take a look at investigation 4, page 533. Now we're going to take a look, instead of the number being in front of the sine x, now we're going to see what happens when it's in front of the x. Okay, so here's our graphs. This, again, the red one is always the sine of x. So let's look and see what sine of 2x does. Okay, sine of 2x changes now, instead of the amplitude, it changes the period. It changes how often the graph repeats. So the graph for sine x normally repeats after 360 degrees. That 2 in front means it's now, you're going to go through twice as many periods in 360 degrees. All right? So hopefully with that, you can figure out that 0.5 is going to then make it, you're going to have only get through half of a period in 360 degrees instead of 1 full period. So that's what the 0.5 is. You're going to get through half a period in 360 degrees. Okay? And then the negative x actually is the exact same graph as negative sine x. Okay, so sine of negative x and negative sine x, same exact graph. If you look at it, they're the same graph. Okay? All right. So back to our Ferris wheel example, this sine of 2x, if you'll remember, you went through the period twice as fast. So now the Ferris wheel, instead of going around in 16 seconds, will go around in 8 seconds. So it's going to go faster. Okay, and then the 1/2 x, instead of going around in 16 seconds, it would go half as fast, so it's going to go around in 32 seconds. All right, and then the negative sine x, again, is going to make it just go the opposite direction. All right, let's see, let's take a look at investigation number 5 from page 535, and that's, now we're putting a number here after the x. So we're going to add 3 here and subtract 2 on that one. So let's get rid of those. Here's sine x. Sine x plus 3 actually takes the whole graph and moves the entire graph. Doesn't change the amplitude, doesn't change the period, but it just changes its vertical placement. So that's the vertical translation here. So it takes the whole graph and moves it up 3. Okay, so 1, 2, 3. Move this up 1, 2, 3, and everything's the same. All right. Hopefully you can then figure out that the x minus 2 is going to take that whole graph and go down 2. All right. So that is that's the vertical translation. All right. Let's take a short little video break.
I'm trying to learn how to read because I read better. Because I hear it's like good for you or something. Anybody here? It's got a good reputation, right? Nobody ever badmouths it. You never see a point counterpoint show about reading. And in the pro side of reading, like a professor with a bow tie. And in the opposite side, hey, let me tell you something. Reading don't never do nothing. Because if you hazarded a book, and you have looks at it, look at it, then you might not even know why you had to do that. I have nothing to add.
All right. So let's look at one more thing here. And that is, we're going to look at the general form y equals a sine of bx plus c. So this c here, we just figured out, this is the vertical translation. Okay. The b here, if you'll remember, this here affects the period. Okay. And then what this b actually does, what you want to do is take the normal period for sine, which is 360 degrees, and you divide by b, and this will give you your the new period. That's how long it's going to take, the new or the revised period. Oops, that's a w. Okay, that's going to be your horizontal. Sorry, that's going to be your horizontal dilation. Okay, so that's going to affect the period. Okay, and then a here, this here, simply just affects the amplitude. Right, it affects if it goes up higher or lower. Basically, the distance between, remember, the principal axis and the max, or the principal axis and the minimum. Okay, so the a here affects the amplitude. All right, we are going to pick the rest of this up on the second half of this 16F video here. Okay, all right.